Hi everyone, this is Dr. Nak. Today we're going to learn about linear equations in two variables and linear functions. For the prep work, make sure to know how to simplify complex fractions. What's complex fraction? It's like fraction within another fraction. And number two, make sure to know simplifying equation by multiplying by the least common denominator. In this section, we're going to learn about graphing linear equations in two variables, determine the slope of a line, apply the slope-intercept form of a line, compute average rates of change, and solving equations and inequalities graphically. Let's get started. So let's first go with the definition of a linear equation in two variables. It says let A, B, and C represent real numbers such that A and B are not both zero. A linear equation in the variables x and y is an equation that can be written in this form: ax plus by equals to c. This is called the standard form of an equation of a line. Now, what makes it linear is this. Remember, A, B, C, they're some numerical values. What makes it linear is that exponent on the variables are always going to be 1. So if you have something like ax squared plus by equals c, that is no longer a linear equation. And that's what I have written here. Note, a linear equation ax plus by equals c has variables x and y, each of first degree. And also, we're going to learn about slope formula. I will write all these out as we go along, but I just wanted to show you what we're about to go over. So let's just go over the sheet. So we have a slope formula coming up, and right after that, we're going to learn how to write an equation of a line in slope-intercept form. And then we're going to learn about the definition of what is a linear function and what is the constant function. And at the very end, we'll learn about how to compute the average rate of change. Let's just jump in and start doing some examples. Example 1, graph negative 2x plus y equals 4. So when you graph this out, I would write this as a function of x. Y equals a function of x, meaning solve for y. So how do we solve for y is you just add 2x to both sides. So then what we're going to get is we get y equals 2x plus 4. We'll eventually learn how to graph without plotting points, but for now, let's do that. Now, all we need is 2 points because we know that this is going to be a straight line. So what I usually do is I just compute the x and the y-intercept and connect the dots and be over. But this will be a good exercise for us to compute from x equals 3 to 2. So let's just do it. All right, and then we can do the x and the y-intercept next. So here you're going to have, when x is negative 3, you're going to have 2 times negative 3 plus 4. That's negative 6 plus 4. That's negative 2. So we will be plotting negative 3 comma negative 2. And when x is 2, then you're going to have 2 times negative 2 plus 4. So in this case, we're going to get 0. So here we have negative 2 comma 0. And when x is negative 1, we have 2 times negative 1 plus 4. That's negative 2 plus 4, so that's 2. So we will be plotting negative 1 comma 2. And when x is 0, you're going to have 2 times 0 plus 4, so which is 4. So we are plotting 0 comma 4. And when x equals to 1, you're going to have 2 times 1 plus 4, so that's 6. So we got 1 comma 6. Oh no, I'm running out of room. And then when x is 2, you're going to have 2 times 2 plus 4. That's 8. So we'll be plotting 2 comma 8. Okay, so let's first plot negative 3 comma negative 2. So you got negative 3 comma negative 2. I think it's right here. And then we have negative 2. When x is negative 2, your y value is 0. So that will be at this point. And when x is negative 1, our y value is going to be 2. And we have 0, 4, where's 1, 2, 3, 4. And 1, 6, 1, 6. And then 2, 8. So 2, 8. And just draw the straight line through it. Now, like I was saying earlier, we already know that this is going to be a straight line, so all we need is 2 points. So what I usually do is I usually just compute the x and a y-intercept and then connect those dots and be happy with it. So let's just do it that way as well, just for fun. So how do you find the x-intercept? You set y equals to 0 and then you solve for x. So here, you're going to set y equals to 0, then you're going to have 2x plus 4. Subtracting 4 from both sides, and you're going to have a negative 4 equals to 2x. Now, dividing by 2, then what are we going to get? We're going to get x equals negative 2. All right, so that's the x-intercept. If I did it that way, then all I have to do is x equals negative 2, so I will be plotting here. And then let's go with the y-intercept. That's what? You set x equals to 0 and then you solve for y. So you're going to have a y equals 2 times 0 plus 4, which means that y equals 4. So that is going to be our y-intercept. So I will be just plotting here. Then you just connect those two dots to draw the straight line. Now let's look at this example here. Let's graph 3x minus 2 equals 4. So do you see the difference between part A and part B? So there is no y. Do you see that? Okay, but we got this. So let's just solve for x and see what we're going to get. So solving for x, so what do? We add 2 to both sides. Then you're going to get 3x equals to 6. Now dividing by 2. Just kidding. Dividing by 3. And we're going to get x equals to 2. Now, x equals to 2 is an equation of a line. So if you want to make the chart, here's x and a y. This is telling you that no matter what the y value is, your x is always going to be 2. So x is always going to be 2, 2, 2, 2. And your y can be anything. Maybe let's go with negative 2, negative 1, 0, 1 or something like that. So do you see what kind of graph that we're going to get? We're going to get a vertical line. So if I plot it, when x is 2, y is negative 2. That's here. When x is 2, y is negative 1. That's here, isn't it? And when x is 2, y is 0. So you got the idea. So here, what we're going to get is we're going to get a vertical line as our graph. All right, our next topic is slope formula. So what is a slope? So let's go. So it says the slope of a line passing through the distinct points x1, y1 and x2, y2 is given by m equals delta y over delta x. Now in a math class, every time you see a delta sign, that's denotes for difference. So this is same thing as difference of y over difference in x. So here, formula is going to be y2 minus y1, and then all over x2 minus x1. Now, since this is a change in a y value, right? So our y value is going to change. So sometimes we call this rise. And then here, your x value is going to change. So your x value is going to change here. So we sometimes call this run. So maybe you've heard the word rise over run is the slope. So that's where it comes from. Anyways, let's do some examples. Example 2, find the slope of a line passing through the given points. So first points that were given are negative 100, negative 16, and the other one is 84, 30. Now, it does not matter which one you want to call x1 and y1, but just be consistent about it. So just so that we all do it the same way, let me just call negative 100 to be x1, and then y1 is negative 16, and then this guy is going to become x2, and then 30 becomes the y sub 2. All right, now let's compute the slope. So the slope is y2 minus y1, whole thing over x2 minus x1. So then we're going to get y2, which is 30, minus y1. So be careful, you're going to have a negative 16 in the parentheses. And then whole thing over x2, which is 84, minus negative 100. So you're going to have minus 100, just like that. Okay, so then this becomes 30 plus 16. And then this becomes 84 plus 100. There you go. So this becomes, what is that? 46 over 184. And simplify that all the way. That's 46 going to 184. I think so. 4 times. So here, our answer is going to be 1/4. Let's do another one. So now we're given the first point is 5, 2, and the second point is negative 3, 2. So feel free to pause the video and try this on your own. Okay, so let's go. So again, what I'm going to do is I'm going to call this one x1, y1, and then x2, y2. All right, so let's go. So m slope is y2 minus y1 all over x2 minus x1. So here we're going to get 2 minus 2, whole thing over negative 3 minus 5, which becomes 0 over negative 8. So what's 0 over negative 8? That's going to be 0. So here it is. But what does it mean? We have a slope equaling to 0. So what kind of graph do you think we're going to get? We're going to get a horizontal line. So let's just plot 5, 2. Let me see. 1, 2, 3, 4, 5, 2. And then let's plot negative 3, 2. Negative 3, 2. And if I draw the straight line through it, we got ourselves a horizontal line. Now, every time you have a horizontal line, guarantee that your slope will always be 0. Now let's take a look at this example here. We're given 2, negative 5 and 2, 1. All right, so again, let me just call this one xy, y1, and then x2, y2, and let's go. So you got a m equals y2 minus y1, whole thing divided by x2 minus x1. So y2 is 1, and then minus y1 is negative 5. And then whole thing divided by 2 minus, and then another 2. So the top becomes 6, and the bottom becomes, oh no, bottom becomes 0. So in this case, your slope is going to become undefined. So what kind of graph do you think we're going to get with the undefined slope? So if you plot those 2 points, you'll see it immediately. So let's plot it. 2, negative 5. So you got 1, 2, negative 2, 3, 4, 5. It's right here. And then we have when x is 2, y is 1. So that will be right here. So now can you tell what kind of graph you're going to get? Yes, a vertical line. So this always happens if you're given a vertical line, your slope is always going to be undefined. Our next topic is slope-intercept form of a line. It says, given a line with slope m and y-intercept 0, b, the slope-intercept form of the lines given by y equals mx plus b. So here, our m is the slope and b becomes the y-intercept, and x and y, they're just variables, so they stay the way they are. So there are 4 different types of slopes of lines. One of them is positive, negative, slope is 0, and then slope is undefined. So here they are. Now, if you're getting the rising graph means you got to look at the graph from left to right. So the first one, your slope is always going to be positive. Now, if you have a falling graph, which is the second line, your slope is negative. And we talked about the slope of the horizontal line and a vertical line. The horizontal line is slope is 0. And for the vertical line, slope is undefined. Let's take a look at example 3. It says, write the equation in slope-intercept form, if possible, and determine the slope and y-intercept. Graph the equation by using the slope and y-intercept. So let's look at the first equation here. So we're given 5x equals 3y minus 6. So here, in order for us to determine the slope and a y-intercept, you want to solve for y equals a function of x, because remember that the slope-intercept form, let me just write slope-int. So if I write slope-int, that means slope-intercept form is given by y equals mx plus b, where m is the slope and the b is the y-intercept. So let's solve for y. So how are we going to do that? Let's see. Maybe we can add 6 to both sides. Then we'll get 5x plus 6 equals 3y. Now dividing by 3, remember when you divide it by 3, you better divide everybody by 3. And let me flip the equation so that y becomes first. Then here we're going to have y equals 5 over 3x and then plus 6 over 3, which becomes 2. So now this is in slope-intercept form, and can you figure it out what the slope is going to be? Slope is going to be the coefficient on x. So in this case, 5 over 3. And the y-intercept is at y equals positive 2. Next, what we need to do is we need to graph this by using the y-intercept and the slope. So first step, plot your y-intercept. So y equals to 2, that's right here. Okay. Now, since, remember, slope is also called rise over run, right? So our rise unit is positive 5 and the run unit is positive 3. So here, what we need to do is this. We need to, from the y-intercept, you're going to go up 5 units. 1, 2, 3, 4, 5. And then from this point, you're going to run positive 3. So in this case, you're going to go 1, 2, 3. Now, after you use your rise over run, make yourself a dot and connect those dots, and that's your answer. So here's the graph of y equals 5 over 3x plus 2. Let's try this one. We're given x over 3 plus y over 4 equals 1. I know, I already know what you're thinking. So you're like, fractions. You got this, okay? So you must become one with the fractions. All right, so let's go. So it's not as bad as you think, all right? So again, let's not forget what we're doing. So first, we want to write this in slope-intercept form. So which is y equals mx plus b. So basically, you need to solve for y from this equation. Now, here is the trick. Multiply both sides by the least common denominator of 3 and 4. Since 1 is same thing as 1 over 1, right? So it basically boils down to a least common denominator between 3 and a 4. What do you think? I think that's 12, because 12 is the smallest number that both 3 and 4 can go in, right? Divide it by nicely. So here, let me just write every step out here. So here, our LCD, so let me just write trick. Multiply both sides by the LCD. Least common denominator, in this case, 12. Okay, so let's see what's going to happen. So first, let me just copy down the equation here. Okay, now what I'm going to do is I'm going to multiply both sides by 12. Now, 12 is the same thing as 12 over 1, isn't it? You don't have to write over 1 if you don't want to, but now what we're going to do is we're going to distribute 12 to x over 3 and then plus 12 times y over 4. Okay, so let me write every step out. So then first term is going to be 12 over 1 times x over 3 plus 12 over 1 times y over 4. And that's going to equal to 1 times 12, which is going to become 12. Now, here is the cool thing. If you multiply everything by the LCD, you should be able to simplify your equation so that on the next step, you will no longer see that fraction. So here, I can cancel 3 goes into 3 once, and 3 goes into 12 4 times, right? And then here, 4 goes into 4 once, and then 12 divided by 4 is 3. So let's clean it up a little bit. So now what do we have left? We have 4 over 1 times x, which is same thing as 4x. And then we have 3 over 1 times y, so which is same thing as plus 3y equals 12. Now look at it. Boom. No more fractions. Now you can smile. Okay, now from here, all you got to do is just solve for y. So we got this. So let's go. So first, let me just subtract 4x from both sides. Then we're going to get 3y equals negative 4x and then plus 12. Now, next step, solving for y, we got to divide by 3. So we got to divide everybody by 3 to get y equals negative 4/3 x, and then plus 12 over 3 is 4. So here, our slope is negative 4/3. By the way, negative 4/3 is exactly the same thing as 4 over negative 3, by the way. Okay, so because I'm telling you this because we're about to do rise over run. So here, we have the rise unit to be negative 4, which means from the y-intercept, you have to go down 4 units. And then over here, from the y-intercept, you have to go 4 units upward. So the next question is, are we able to get exactly the same line by rewriting our slopes? The answer is yes. But anyways, let's just start on this. So then what is the y-intercept? So the y-intercept, let me just write it above. Y-intercept is the y-coordinate, so y equals 4. Okay, let's first plot the y-intercept. Y equals to 4, so that's 1, 2, 3, 4. So here's our y-intercept. Now, let me use this slope first, negative 4 over 3 to draw the line. Okay, so here, if I have negative 4, so that's the rise value, so we have to go 4 units downward. 1, 2, 3, 4. And our run value is positive 3, isn't it? So you're going to have to go right 3 units. You're going to go 1, 2, 3. Then you make yourself a dot, and then you connect those dots to draw the straight line. All right, so that's by using negative 4 on the top and then over positive 3. Now let's check this one out. So let me just change the color. So let's take a look at this guy here. So what we're going to do is this. We're going to do the same thing, but here I toss the negative on the bottom instead of keeping it on the top. So here, if I follow this, so here is still the y-intercept. Now from here, oh no, I'm about to run out of room. Oh well. Okay, so here you're gonna have to rise 4 units above, right? So 1, 2, 3, 4. And then you're gonna have to go 3 units from here to the left because you have a minus 3. So you're gonna go 1, 2, and then 3. And then here you're gonna be plotting a dot. Now if you connect this with a straight line, do you see that this line and the blue line is going to overlap? So no matter which way you're going to use the slope, you will still get the same exact line. Our next topic is linear and constant functions. So it says let m and b be real numbers and m does not equal to 0. Then, number 1, a function defined by f of x equals mx plus b is a linear function. The graph of a linear function is a slanted line. Number 2, a function defined by f of x equals b is a constant function. The graph of a constant function is a horizontal line. Example 4, determine if the function is linear, constant, or neither. All right, so let's look at example A. We're given f of x equals 3x plus 2. So what do you think? I think this is a linear function because it looks like f of x equals mx plus b, where m is 3 and b is 2. So in this case, it is a linear function. Now let's look at part B. We're given g of x equals 3 over x plus 2. Now what do you think? This is neither, because this is not just g of x equals a constant because you have a variable x appearing. However, variable x appears on the bottom of the fraction, right? So that is not of the form f of x equals mx plus b. So in this case, this equation is neither linear or constant. So I'm just going to write it as neither. Do you say neither or neither? Whatever, I'm just going to call it neither. All right, so then let's look at the next one. Part C, h of x equals 3. So I think you got this one. So this is of the form f of x equals b, where b is a constant. So this is a constant function. All right, now let's look at the last one. P of x equals 3x. What do you think? I think this is linear because this is of the form mx, now plus b, but there is no b, right? Which means what? Plus 0. B must be 0. Okay, so in this case, yes, this is still linear function. All right, now let's do example 5. It says use slope-intercept form to write an equation of a line, passes through the given point, and has the given slope. So let's first look at the first example. We're given a point, which is -4, -2, and we're given slope is 3 over 2. So what we need to do is first, let's write down the formula for the slope-intercept form. So the slope-intercept, let me just write it as slope-int. Int means intercept, is y equals mx plus b. So here we're given the slope, so let's just plug that value in. So right now we have y equals 3 over 2x and m plus b. Now in order to do this problem, we still have to find the value of b. So what we need to do is we have to use the fact that -4, -2, your line has to pass through that, which means what then? It must lie on the graph, which implies that -4, -2 must satisfy the given equation. All right, so let me just write that out. So how can I write this? So since -4, -2 is on the graph, it must satisfy the equation. EQ means equation. Okay, so what we're going to do is this. We're going to replace our x with -4 and y with -2, so that way we can solve for b. Ready? So then here, we're going to have a -2 equals 3 over 2, and then our x was -4, and then here you're going to have plus b. Let's simplify this a little bit. 2 goes into 2 once, into 4 twice. So we now have -2 equals, who's left over here? -2 times 3, so that's -6, and then plus b. My b and 6 looks the same. Sorry, this is the variable b. Okay, so now we need to add 6 to both sides to solve for b. So here our b is going to be 6 minus 2, which is going to become 4. So let me just box this because I need this piece of information. All right, so therefore, our equation in slope-intercept form is given by y equals 3 over 2x and then plus 4. Now let's look at the next example. So we're given -1, -3. So your line is going to pass that point, and the slope is 0. And we still want the slope-intercept form. So let me just write that out. Again, that's y equals mx plus b. All right, so now since we're given the slope, right, which is 0, let's plug that in. So we have y equals 0x plus b. Okay, so then what is that going to become? Y equals to b. So here, the variable x disappears, but it's okay. We're going to follow the same thing as what we did. So since we know that the -1 comma -3 is on the line, which means that it must satisfy the equation, right? So here, what is the y coordinate of the given point? Isn't it just -3? So here, we just set y is -3, and that's going to equal to b, and we're done. So this is going to be our y-intercept. So again, slope is 0. Do you remember what kind of line that we're going to get? We're going to get the horizontal line. Okay, so let's write them out. So therefore, the slope-intercept form is given by just the y equals, so 0x is going to disappear, so it's just going to be b. So y equals -3. So here is the graph of it, in case you're interested. Our next topic is average rate of change of a function. So let's just read together here. It says, suppose the points x1, y1 and x2, y2 are points on the graph of a function f. So let's note this, x1 and y1. So isn't it y1 is the corresponding y value when x is denoted by x sub 1. So if y equals f of x, then do you see that this is equivalent to f of x sub 1? Because y sub 1, remember y equals f of x. So in this case, y1 must equal to f of x1. And then here, same thing, x2 comma y2, I can rewrite that as x2 comma f of x2. And if f is defined on the closed interval, some x values, let's just say x1 comma x2, then the average rate of change of f is the secant line containing x sub 1 comma f of x sub 1 and x sub 2 comma f of x sub 2 defined by, so this is the little shorthand notation for average rate of change, is nothing but a slope, same thing as the slope formula, delta y over delta x, which is difference in y over difference in x. Now, since y1 became f of x1, and then y2 is f of x2, next step, what we're going to do is we're going to replace our y2 with f of x2, and then y1 with f of x1. So the average rate of change formula is going to be f of x2 minus f of x1, whole thing divided by x2 minus x1. Maybe this whole thing sounded a little bit gibberish, so let me draw you a picture. Okay, so let's just pretend that this is some x value, just call it x1 and then x2. Now here, what is the corresponding y value if I call this function y equals f of x? So this height right here should be f of x1, isn't it? So this height right here should be f of x1, same thing as y1. And then this height here, goodness, oh no, you get the idea. This height, the y value, that's what I'm talking about, is going to be f of x2. Because the way I drew it, maybe it's not straight, but this is defined at x2. All right, so this is the situation, and what the heck is a secant line? So secant line is nothing but a line that is going to connect two dots together here. Now, if I write this point in ordered pair, then this is x1 comma f of x1. And this point right here is x2 comma f of x2, right? Now, do you remember how to compute the slope given 2 points? These 2 points. So here, remember the slope formula was, let me just write it out. slope was y2 minus y1 all over x2 minus x1, right? So in this case, pretend that this is your y, sorry, that's not our y, that's x. Sorry, pretend this is your x1, y1, and then x2, and then y2. So if I follow that, then do you see that we're gonna get f of x2 minus f of x1, whole thing divided by x2 minus x1. So this is nothing but the slope of our secant line, isn't it? Okay, so what is the average rate of change of f? Is nothing but the slope of the secant line. You'll learn more about average rate of change of a function in first semester calculus, so wait till you get there. It gets really exciting. So here's example 6. Given f of x equals x cubed plus 2, find the average rate of change of f from x1 equals -3 to x2 equals to 0. Let's try to graph this out to see what kind of graph that we're dealing with and where the secant line is, because we're going to be computing the slope of that secant line. So right now, only way we know how to graph this out without using a graphing calculator is plotting points. Eventually, you'll learn this by doing the transformation of graphs. But anyway, so let's go. So here I'm going to make a chart, and then y is x cubed plus 2. Okay. And then we want to compute the average rate of change of f from x1 equals to -3 to x2 equals to 0, right? So we're going to have to start from -3. So let's go -2, -1, 0. You can't stop here, but what the heck? Let's just compute when x equals 1 as well. So here you're going to have a -3 cubed plus 2. So that's -27 plus 2, so which is -25. So, oh no, I'm running out of room. So let me just write down here. Where can I write this? You know what? Let me just go right here. So then -3 comma -25. That's where we're going to be plotting. And when x is -2, you're going to have -2 cubed plus 2. So that's -8 plus 2, which is -6. So we're going to be plotting -2 comma -6. And when x equals to -1, we got -1 cubed plus 2, which is -1 plus 2, which becomes 1. So we got -1 comma 1. And when x is 0, we all love it when x is 0, no? This is 0 cubed plus 2, so that's 2. So we're going to be plotting 0 comma 2. That's the y-intercept. And we're going to have 1 cubed plus 2, which is going to be 3. So here is 1 comma 3. All right, let's graph this out. My apologies for the grid of the graphing paper being super small, but we have to plot y equals to -25. So that's the reason why I have to shrink this grid a little bit. So hopefully you can see this. So let me just go with when x equals to -3, our y is -25. 6, 7, 8, 9, 10. That's -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and a 10. So that's -20. 1, 2, 3, 4. Oh, Justin. We made it. Okay, so here, let me just plot -3. Oh my gosh, my eyes. -3. Oh my gosh, where are you, -3? And then -25. Yikes. Okay. And the next one is going to be -2 comma -6. 1, 2, 3, 4, 5, 6. So that's -6. So here we're going to be plotting, oh dear Lord. Okay, right here. All right. And the next one is -1 comma 1. So that's -1 and then 1 up in here. So we're going to be plotting right here. And then next one is 0 comma 2, so that will be here. And 1 comma 3, so 1 comma 1, 1, 2, 3. Oh, this is such a tight squeeze of the graph here. So again, my apologies, but if you draw this really big, then you should be able to see the better graph. But this graph is going to go like this. Here we go. You know my skills, right, when it comes to drawing graphs. Okay, bear with me. I can do this. I can do this. Let me just go from this angle here. Oh gosh. What kind of line is that? Okay. Oh, that is the most ugly looking graph, but please graph this on your graphing calculator. And now what we're about to do is this. Let's draw the secant line where x1 equals to -3 to x2 equals to 0. So that's precisely this point. We're about to draw a straight line from this point to when x is 0, so which means this point here. All right, so let's try to do that. Okay, I'm sorry, I had to kind of like tilt the graphing paper so that the straight line that I drew will actually intersect the 2 points that I want them to. So I'm trying to make this line intersect this point and then this point. So this purple line is called the secant line. And what we want to do is we want to find the slope of that secant line, which is precisely the average rate of change of f. Okay, so let's do it. So first, let's write down the formula for the average rate of change. So that's given by f of x2 minus f of x1, whole thing divided by x2 and then minus x1. So since x2 is 0, basically we're computing f of 0 minus f of, now x1 was given to be -3, and then whole thing over x2, which is 0, minus x1. Be careful right here, you're going to have a minus 3. Okay, so then here, let's compute f of 0 and f of -3 as a side work. All right, so where can I write this? Okay, let me just work right here. So side work, let's compute f of 0. Okay, so what we need to do is, here is our f of x. We're going to replace its x with the 0. So here the expression that you're going to get is 0 cubed plus 2. So that's just 2. So that's the value of f of 0. Now let's compute f of -3. So that's going to be -3 cubed and then plus 2, which is -27 plus 2, which is -25. Now let's plug that in, and we're going to get f of 0 was 2 minus f of -3 was -25. And then all over, so you're going to have -3, so this is going to become +3. So here, what are we going to get? This is 2 plus 25 over 3. So which is 27 over 3, which is 9. So here, it kind of makes sense because look how steep that line is, right? Steeper it is, bigger value for the slope that you're going to get. So here our answer is going to be 9. How's everybody doing? I know it's rough, I know, but we have just one more topic to cover in this section. So hang in there and let's get started. So our last topic in this section is solving equations and inequalities graphically. So let's just bust out some examples. Example 7, solve the equations and inequalities graphically. So here we have x plus 1 equals 2x minus 2. So since we have to do this graphically, so first we need to graph these two equations out. So let me call this one the first graph. So let's just call this like y1. And then let's call this graph y2. And we're going to work this as a side work and to figure it out what the graph is going to look like. So let's go with the side work for 1. So here we have y1 equals x plus 1, right? So which means what then? What is the slope? Slope is, remember, slope is the coefficient on x, but remember there is an invisible 1 sitting here. So our slope is 1, and the y-intercept is at y equals to 1. All right, so keep that in mind, and let's just get the next side work over with. So side work for 2, we're given y2 equals 2x minus 2. So here our slope is 2, and the y-intercept is y equals negative 2. Now let's graph them out. Okay, let's first graph y1 equals x plus 1. So here our y-intercept is y equals to 1. So that's y equals to 1. And then slope is 1, right? But isn't 1 same thing as 1 over 1? So let me just, where can I write this? So m equals to 1 is same thing as m equals 1 over 1. So you're going to rise 1 unit above, 1 unit to the right. So you're going to make a dot here. So then you just connect those 2 dots to draw the line. Now let's graph y sub 2. So the y-intercept is negative 2. And then slope is 2. So that's same thing as 2 over 1. So we're going to go 2 units above and then 1 unit to the right. Make yourself a dot, and then we're going to draw a line through these 2 points. Okay, now let's answer the question. So the question says solve the equation graphically. So here we have y1 equals y2. So that's the equation that we want to solve, right? Graphically. So here's our y1, but this better equal to y2. So what do you think we're looking for? Yes. Whereas the y1 equals to y2 is where the 2 lines intersect. So that will be at this point right here, which is, what is that, 3, and then comma 4 looks good to you? All right, so here we're going to have 3 comma 4 is where y1 must be equal to y2. And that's exactly what the question is asking us to do. So let's write down the answer at the very bottom. So therefore, y1 equals to y2 at 3 comma 4. And that's going to be our answer. Let's look at the next question. We want to find where x plus 1 is less than or equal to 2x minus 2. So again, this is the same exact graph that we just drew. So let me bring that up. So here's the same graph. Now what we're looking for is this. Where is y1 less than or equal to y2? So let me just write that out. So remember, this is our y1 and this is our y sub 2. So basically, we got these situations going on. Where is y1 less than or equal to y2? Which is same thing as saying, where is y1 below the graph of y2? So let's investigate that. So here is your y1, here is your y2. So where is y1 below the graph of y2? I think that's from 3 all the way up to infinity, isn't it? Because this line, y1 is going to keep going like this way, and then y2 is going to keep going this way. So from x equals to 3 on, your y1 is going to be below the graph of y2. So our answer is going to be, so therefore, y1 is less than or equal to y2 on close to 3 to positive infinity. Okay, so let's look at part C. X plus 1 is strictly greater than 2x minus 2. So again, here is our y1, and this is our y sub 2. So basically, this is asking us, where is y1 strictly greater than y2? Which is same thing as saying, where is y1 above the graph of y2? So let's take a look. So here's again, this is your y1, this is your y2, right? So y1, where is y1 above y2? Well, isn't it? It's gonna end at x equals to 3, but 3 is not included because we have a strict inequality here. But do you see that it's gonna be, so this line's gonna keep going down, down, down like this, and then this pink line is always gonna be below the blue curve from negative infinity all the way up to x equals to 3. However, we have a strict inequality here, so our answer is going to be negative infinity to 3 open. So let me just write it. So y1 is strictly greater than y2 on negative infinity to 3 open. Gosh, that was another long section, wasn't it? But I just like to do a bunch of examples because I feel that more examples that you see, better you're going to get at in math. So I apologize if I'm doing way too many examples, but you know, you can always fast forward. Or, you know, I hear my voice sometimes and it's so annoying. So you can just mute me and you can just look at the PDF file if you prefer. But anyways, I just wanted to say great job, everyone, and keep up the great work. And I will talk to you in next section. All right, bye.